In 2007, a water scientist in South Africa made a discovery that should have bankrupted the irrigation industry. Her name was Dr. Inga Jacobs-Mata. She worked at the University of Pretoria, studying water efficiency in agriculture. Her country faced a water crisis. Farmers were pumping aquifers dry, rivers were shrinking. The future of South African agriculture was in question. She was testing every irrigation method ever documented: sprinklers, drip systems, flood irrigation, subsurface tape, anything that delivered water to plants. Then her research assistant brought her a clay pot. Not a fancy pot, a simple unglazed terracotta jar, the kind you could buy at any garden center for a few dollars. The assistant had read about an ancient technique and wanted to include it in the trials. Dr. Jacobs-Mata was skeptical. She was testing sophisticated modern systems. A clay pot seemed almost insulting. She included it anyway. Science requires testing everything. 12 weeks later, she sat staring at data that made no sense. The clay pot had outperformed every modern irrigation system in her laboratory. Not by a small margin, by a factor that should have been impossible. Water efficiency, 90%. 90% of every drop placed in the pot reached plant roots. The best modern drip system in her trial achieved 65% efficiency. The industry standard sprinkler achieved 45%. A $2 clay pot was twice as efficient as $1,000 technology. She ran the trial again, same results. She expanded the trial to field conditions, same results. She brought in outside observers to verify her methodology. The results held. Dr. Jacobs-Mata had proven that the most advanced irrigation technology on Earth was a buried jar invented 4,000 years ago. She published her findings. She presented at conferences. She contacted the irrigation industry. The industry was not interested. A $2 solution that eliminates the need for expensive equipment is not an opportunity. It is a threat. Today, we are opening the file on the irrigation technology that outperforms everything modern engineering has created. A clay pot that delivers water with 90% efficiency. A system that costs $2 and lasts 20 years. And the $10 billion industry that has made sure you never learned it exists. If this matters to you, subscribe and hit the bell. The file is open. The technology is called Olla irrigation. Olla is a Spanish word meaning pot or jar. The technology is exactly what the name suggests. A pot buried in the ground filled with water, delivering moisture directly to plant roots. The science is elegant. Unglazed terracotta is porous. Under a microscope, the clay reveals millions of tiny channels running through its structure. These channels are large enough for water molecules to pass through, small enough to prevent bulk flow. When you fill a buried olla with water, physics takes over. Water moves from areas of high concentration to areas of low concentration. Inside the pot, concentration is high. In dry soil outside the pot, concentration is low. Water seeps through the clay walls, molecule by molecule, driven by this gradient. But the system does something that no modern technology can match. It self-regulates. When soil around the olla is dry, the concentration gradient is steep, water moves quickly through the clay, the plant receives abundant moisture. When soil becomes moist, the gradient decreases, water movement slows, the plant receives less because it needs less. When soil is saturated, the gradient disappears, water movement stops. Not a single molecule leaves the pot until the plant consumes what is already in the soil. No sensor can match this precision. No timer can anticipate plant needs this accurately. No smart controller can respond to soil conditions with this sensitivity. The Olla does not measure moisture and calculate response. It is the response. The physics of porous clay creates perfect irrigation automatically. Plant roots learn where the water is. Within days of Olla installation, root behavior changes. The roots sense the moisture gradient radiating from the clay. They grow toward it. They cluster around the pot, forming dense networks that capture every molecule of water that seeps through. Dr. Jacobs-Mata documented this root clustering in her trials. Plants irrigated by Ollas developed root systems fundamentally different from plants irrigated by surface methods. Surface-irrigated roots spread horizontally, searching for the unpredictable moisture that comes from above. They remain shallow, vulnerable to drought between waterings. Olla-irrigated roots concentrate around the reliable moisture source. They grow deeper and denser. They become more efficient at water uptake and more resilient during dry periods. The plant is not just receiving water more efficiently, it is developing the architecture to use water more efficiently. This is why Olla irrigation produces better plants, not just surviving plants. The history of Olla irrigation spans 4 millennia. The oldest evidence comes from northern China, approximately 2000 BCE. Farmers in arid regions buried clay vessels near their crops. Water was carried from distant sources at enormous labor cost. Wasting it was unthinkable. These farmers discovered that water placed inside buried clay pots remained available to plants far longer than water poured on the surface. They did not understand the physics. They understood the results. The technology spread along trade routes. By 1000 BCE, Persian farmers had adopted and refined the technique. Persia was a desert empire. Agriculture required irrigation. Irrigation required efficiency. Ollas provided efficiency that no other method could match. The Persians developed specialized ollas for different crops, small vessels for vegetables, large vessels for fruit trees, networks of connected vessels for field crops. The technology became sophisticated without becoming complicated. The Romans encountered Olla irrigation when they conquered the Middle East. They documented it in their agricultural texts. Columella, writing in 65 CE, described burying clay vessels near trees to provide consistent moisture through dry seasons. Arab scholars preserved the knowledge through the medieval period. They carried it across North Africa into Spain and eventually to the Americas. When Spanish missionaries arrived in what is now Arizona and New Mexico, they brought Olla irrigation with them. They intended to teach the indigenous people this advanced technique. They discovered the indigenous people already knew it. The Tohono O'odham people had been using buried clay vessels for generations. Different continent, different culture. No possible contact with the old world. They had independently invented the same technology. This independent invention is significant. It tells us that Olla irrigation is not a cultural artifact. It is a discovery, a natural solution that any people facing water scarcity will eventually find. The physics of clay and water and plants leads inevitably to the same conclusion. Bury the pot, fill it with water. Let physics do the rest. Every civilization that needed water efficiency discovered Ollas. Every civilization that forgot them had to rediscover them. We are in the forgetting phase. The forgetting began with abundance. For most of human history, water was precious. Carrying it required labor. Wasting it was unacceptable. Every drop mattered. Under these conditions, Olla irrigation was obviously correct. Why lose half your water to evaporation when you could lose almost nothing? The calculus shifted when water became cheap. Electric pumps and pressurized pipes made water abundant for the first time in human history. Farmers could flood fields. Homeowners could run sprinklers. Industry could waste water because water cost almost nothing. Efficiency stopped being a virtue. Volume became the measure of success, and volume created an industry. The global irrigation equipment market generates approximately $10 billion per year. Pumps, pipes, sprinkler heads, drip emitters, timers, controllers, sensors, valves, fittings, installation services, maintenance contracts, $10 billion per year, dependent on one assumption: that irrigation requires complicated equipment. An Olla is not complicated equipment. An Olla is a pot, a $2 pot that works better than everything the industry sells. The industry did not suppress Olla irrigation through conspiracy. They simply did not mention it. Extension services taught modern methods. Garden centers sold modern equipment. Magazines featured modern systems. Ollas were not taught, not sold, not featured. The knowledge did not disappear. It stopped being transmitted. Your great-great-grandparents might have known about Ollas. Your great-grandparents might have known. The chain broke somewhere in the 20th century when the irrigation industry became an industry. Today, most gardeners have never heard of Olla irrigation. They struggle with watering schedules. They watch plants wilt between applications. They spend hundreds of dollars on equipment that performs worse than a $2 pot. They do not know what they do not know, and no one with economic incentive tells them. The efficiency comparison is devastating. Surface irrigation, the oldest method, delivers water to the soil surface. The sun evaporates a significant percentage before it can soak in. More evaporates from the wet soil surface. Of the water that reaches the root zone, much drains past before plants can use it. Efficiency, 30 to 40%. For every 100 gallons applied, plants receive 30 to 40. Sprinkler irrigation sprays water into the air. Evaporation begins immediately. On a hot, windy day, half the water evaporates before reaching the ground. Of wet lands, much evaporates from leaf surfaces before reaching soil. Efficiency, 40 to 50%. Slightly better than surface irrigation, but water is still lost to air. Drip irrigation delivers water directly to soil surface near plants. It eliminates spray losses, but water still evaporates from wet soil, and emitters clog, requiring maintenance and replacement. Efficiency, 60 to 70%, the best modern technology widely used. Olla irrigation delivers water underground, directly to root zone through self-regulating physics. Efficiency, 85 to 95%. Not slightly better, dramatically better. 1.5 times more efficient than the best modern alternative. 3 times more efficient than standard sprinklers. A garden that requires 100 gallons per week with sprinklers requires 35 gallons per week with Ollas. During water restrictions, during droughts, during shortages, this difference is the difference between dead gardens and thriving gardens. Dr. Jacobs Mata was not the only researcher to document these numbers. In 2003, researchers in India tested Olla irrigation against drip irrigation for tomato production. The Ollas used 50% less water and produced 25% more fruit. Less water, more yield, from a pot versus sophisticated equipment. In 2009, researchers in Pakistan documented similar results for vegetable production. water savings of 50 to 70% with equal or improved yields. In 2014, researchers in Brazil tested Ollas in semi-arid conditions. Plots irrigated by Ollas survived drought conditions that killed surface irrigated control plots. Survival versus death. Same amount of water applied differently. In 2018, researchers at the University of Arizona compiled a meta-analysis of Olla studies worldwide. Across dozens of trials in multiple countries, the results were consistent. Water savings of 50 to 80%, yield maintenance or improvement, performance in conditions that killed plants using other methods. The research is published. The science is settled. The data is available. The irrigation industry continues selling sprinklers. Building an Olla system requires almost no money and almost no skill. The materials are simple. Unglazed terracotta pots. Any garden center sells them. Any thrift store has them. Price, $1 to $5 per pot. The pot must be unglazed. Glazed ceramic seals the pores that allow water to seep through. Test by wetting the pot surface. If water soaks into the clay, it will work. If water beads on the surface, the pot is glazed and will not work. Size determines coverage area. A 6-inch pot irrigates a radius of approximately 12 inches. A 12-inch pot irrigates a radius of approximately 24 inches. Larger pots water larger areas. The installation is simple. Dig a hole slightly larger than your pot. Place the pot in the hole so only the rim and opening remain above ground level. Fill soil around the pot, pressing gently to eliminate air pockets. Cover the opening with a stone, broken pottery piece, or terracotta saucer. This prevents mosquitoes from breeding in the water and reduces evaporation from the pot opening. Fill the pot with water. Refill when the water level drops. That is the entire system. No pipes to connect, no emitters to position, no timers to program, no filters to clean, no winterization beyond emptying the pots before freeze. A child can install an Olla. A child can maintain an Olla. The technology requires no expertise because it requires no complexity. The applications extend to any scale. For a single tomato plant, bury one small Olla beside it at planting time. Fill weekly. The plant will never experience drought stress. For a raised bed, install 3 or 4 Ollas distributed evenly across the space. Each pot covers its radius. Together, they irrigate the entire bed. For a large garden, create a grid of Ollas. Calculate spacing based on pot size and coverage area. A garden that previously required daily attention needs attention twice per week. For fruit trees, use larger Ollas or multiple smaller ones. Position them within the drip line where feeder roots concentrate. Young trees establish faster because they never experience drought stress. For containers, partially bury small Ollas in the potting mix. Container plants are the hardest to keep watered in summer. An Olla transforms daily watering into weekly watering. The system scales from a single pot plant to a commercial operation. The physics remain the same at any size. The cost comparison favors Ollas overwhelmingly. A basic drip irrigation system for a small garden costs $50 to $200. It requires annual maintenance. Emitters clog with mineral deposits. Tubing degrades in sunlight. Expect replacement every 3 to 5 years. A smart irrigation controller costs $100 to $300. It requires Wi-Fi connection, electrical power, and often subscription services for full functionality. It optimizes timing, but does nothing about the fundamental inefficiency of surface application. A professional irrigation installation costs $1,000 to $5,000 depending on garden size. It includes trenching, buried pipe, automatic valves, and controllers. It looks impressive. It still wastes more water than clay pots. 10 Ollas cost $20. They last 20 years or more. They require no maintenance, no electricity, no subscriptions, no professional service. $20 versus thousands of dollars. 20 years versus 5 years. Zero maintenance versus constant maintenance. The industry prefers that you do not make this comparison. The Ollas have limitations, they freeze. In cold climates, water inside Ollas expands when frozen, potentially cracking the clay. Empty and store Ollas before hard freezes. Reinstall in spring. They require manual filling. There is no automation. You must visit your garden, see your plants, fill your pots. Some consider this a drawback. Others consider it a feature. They work best in loose soil. Heavy clay soil restricts root penetration toward the Olla. Amend clay soils with compost to improve structure before installing Ollas. They attract nearby roots. Weeds near Ollas will send roots toward the moisture source. Mulch around Ollas to suppress weed growth. None of these limitations are severe. None of them outweigh the benefits. They simply require awareness. The question is why this technology remains unknown. Millions of gardeners struggle with watering. They watch plants wilt. They check soil moisture anxiously. They install expensive systems that underperform. The solution costs $2. The solution has been proven for 4,000 years. The solution is available at any garden center, and almost no one knows it exists. This is not accident. This is economics. A gardener who knows about Ollas does not buy drip systems, does not buy smart controllers, does not hire irrigation professionals, does not purchase replacement parts. A gardener who knows about Ollas exits the market permanently. The industry needs ignorance to survive. They do not suppress Ollas through active conspiracy. They simply do not mention them, do not teach them, do not include them in product offerings, do not fund research that promotes them. They sell what makes money. They ignore what does not. The economics of Ollas are perfect for gardeners and terrible for companies. A product that costs $2 and lasts forever cannot support a business. A technology that requires no expertise cannot employ consultants. A system that never fails cannot sell replacement parts. Ollas are economically inconvenient, so they remain culturally invisible. Dr. Jacobs-Mata continued her research after the initial trials. She tested Ollas against every new irrigation technology that entered the market. Smart systems with soil sensors, precision drip with pressure compensation, subsurface irrigation with automated controls. The Ollas kept winning, not by small margins, by the same overwhelming margins she had documented in 2007. 90% efficiency versus 60 or 70% for the best modern alternatives. She published paper after paper. She spoke at conferences. She worked with South African Agricultural Extension Services to promote Olla adoption. The adoption remained minimal. Commercial farmers said Ollas could not scale. This was false. Traditional farmers in India and Pakistan use Ollas on operations producing food for markets. Home gardeners said Ollas were too primitive. This was cultural bias. A technology is not primitive because it is old. A technology is primitive if it does not work. Ollas work better than anything modern. Industry representatives said Ollas were impractical. This was self-interest disguised as advice. The resistance came from everywhere. The data came from Dr. Jacobs-Mata's laboratory. The data won every argument. But data does not sell products. Marketing sells products. And the marketing budget for Ollas is zero. The irrigation industry spends millions on advertising, trade shows, and promotional content. They shape what gardeners believe about watering. Ollas have no industry, no advertising, no trade shows, no promotional content. The competition is not fair. But the physics remain true regardless of marketing budgets. A $2 pot still outperforms $1,000 systems. The water crisis makes this knowledge urgent. Aquifers across the American West are depleting. The Ogallala, which irrigates the Great Plains breadbasket, has dropped over 150 feet in some areas. It will be functionally exhausted within decades. The Colorado River no longer reaches the sea. Every drop is allocated before it completes its natural course. States are fighting over water that no longer exists in sufficient quantity. California, Arizona, Nevada, and New Mexico face water restrictions that will intensify. Gardens that waste water will become unacceptable. Gardens that cannot prove efficiency may face prohibition. In this future, Olla irrigation is not quaint. It is essential. A garden that uses 90% of its water efficiently is a garden that survives restrictions. A garden that uses 40% efficiently is a garden that gets banned. The technology that seems like a curiosity today may be mandatory tomorrow. The industry will not prepare you for this. They will sell you equipment until the water runs out, then sell you different equipment. Ollas prepare you for this. They work when water is abundant and when water is scarce. They work when restrictions are loose and when restrictions are tight. They work because physics works, and physics does not care about industry profits. 4,000 years of proof. Every civilization that faced water scarcity discovered Olla irrigation. The Persians, the Chinese, the Romans, the Tohono O'odham, they discovered it because it works. They used it because nothing else matched its efficiency. They passed it down because it solved the problem of keeping plants alive with limited water. We forgot it because water became cheap and industries became powerful. The water is becoming expensive again. The industries remain powerful. But the knowledge is not lost. The physics has not changed. The clay pots still sit in garden centers waiting to be buried. Dr. Jacobs-Mata's data remains published. The meta-analyses remain available. The proof is overwhelming and accessible. The only thing missing is awareness. Now you have awareness. A $2 pot, buried beside your plants, filled once per week, delivering water with 90% efficiency while modern systems waste half of what they apply. Technology that outperforms everything the industry sells, available at any garden center, requiring no expertise, no maintenance, no ongoing cost. The most efficient irrigation system ever invented, waiting for you to remember what humanity knew for 4,000 years. If this video helped you, subscribe and hit the bell. Every share teaches what they wanted forgotten. The next video opens soon.